Welcome back everyone to the online conference, Food Innopolis International Symposium 2020, the quest for sustainable food system.
For the last one topic of section, ethnic flavor, Oriental Delicacy, Dr. Christina Liew, Regional Applications Chemist from Gerstel LLP Singapore, will present us the flavor analysis from basics to advanced. Please welcome.
Hi everybody. So thank you for the invitation to Food Innopolis International Symposium 2020. I'm honored to be your speaker now. I'm Christina Liew. I'm from Gerstel. So today I will cover on how to perform flavor analysis, which was actually slightly covered by our previous speaker. And I'll also cover what are the different techniques you can apply in this field. So a short introduction of our company. Gerstel is actually founded in 1967 in Germany. We are a company that is focused on providing our food, flavor, and fragrances customer with automated sample preparation solution. We have high quality, technically advanced analytical systems that are designed in a modular way, which means we can have specific design for cater to different needs of our different customers in the food, flavor, and fragrance industry. So for today's topic, in flavor analysis, as covered earlier by Dr. Sidiwat and Associate Professor Dr. Yawapa, we know that in flavor analysis that there's two big portions to it. We have the aroma portion and the taste portion. So for the aroma portion, how we taste it or smell it is that we smell the volatile compounds coming out of your food. And then after you taste it, which is usually referring to the non-volatile compounds. So when we talk about flavor, we are actually referring to both of these together. Both aroma plus the taste actually mix up the flavor. So today I'll focus more on the aroma because aroma analysis is one of the challenging parts in the flavor analysis. In aroma analysis, in aroma studying, it is actually very personal. Because if I like what I smell, I'll think it's fragrant. And if I don't like what I smell, I'll call it odor. So I think for for Thailand, for Malaysia and Singapore, I believe our favorite food is like durian. To me, it's a fragrant, but I believe this same answer cannot be applied to our friends, for example, in Europe or in US. So the problem with aroma analysis is that when we want to study them, but they are actually usually a group of multiple compounds. So for example, just now covered by Dr. Sidiwat, when he talked about soya sauce, the number of aroma compounds there are in just the soya sauce or in the rice berry. And it's not just a mixture. They are of a mixture of different composition, and some of their concentration can be really, really low. So to do a good aroma analysis, we have to first understand what are these aroma compounds. So aroma compounds are compounds that produce a smell to us as humans, and they are usually these small organic compounds that are readily dispersed in the air. In fact, for human research, a researcher actually estimated that as humans, we can actually distinguish or differentiate up to 1 trillion different types of smell. This makes our sense of smell actually quite strong, and we can also detect them at extremely low concentration. So this makes our nose actually detect better than some of the detectors that we have. But the problem is human, when we do smelling, we usually smell an odor and relate it to a whole emotional experience. So we don't smell them as individual components in your aroma analysis. We smell it as a whole. So there's a need for separation. For example, when I smell the musky or woody smell, I immediately think of my uncle's car. I can't think of what is the individual components inside the smell. So with this information, this makes gas chromatography the perfect instrument to separate and analyze these aroma compounds. So a quick recap, Gas chromatography is actually a very common type of analytical instrument used to separate and analyze these volatile compounds that can be vaporized without decomposition. So wherever you inject, when it goes through the long GC column, as it goes through separating with the gas flow, it will separate into each individual component. A typical system is what you see here on the right. We have the GC using for separation. We have the MS for detection. And we also usually have an odor sampler that helps you to do sample preparation and injection of the sample. So for aroma analysis, a very common instrument that we also have is the olfactory detection pot. This was also briefly covered by our previous speaker. So this technique, when you make use of olfactory detection pot, is known as GC-Olfactometry or gas chromatography olfactometry, GC-O. This is a term you use when you use a human assessor to detect and evaluate each of the individual compounds when they elute after a GC separation. The reason why we need a separate human assessor on top of the current GC detector is because odor strength itself is actually not related to their mass at all for each of the compounds. So this makes the standard GC detector, such as your mass specs, your FID, not a very good representation. So the best instrument to measure the odor strength of aroma compounds will have to go back to our own nose. So in performing gas chromatography olfactometry, GC-O, first, our compounds have to be separated by the GC itself before it is simultaneously detected with another GC detector. A human will actually sit at the olfactory detection pot and will give the descriptors, how long they are, what is the strength of the odor that they are smelling coming out from each of the separated compounds from the GC. So this is where the Gerstel olfactory detection pot will be there, present. So other than allowing you to do compound sniffing, it comes with a voice recognition software and an intensity indicator to achieve feedbacks from the human assessor as they smell these compounds coming out of the GC column. Also, after having this information, they will then be automatically annotated onto the chromatogram that you achieve so that you can cross-reference across the information you obtain with the other detector. Of course, it is designed for flexible so that multiple human assessor, so multiple human assessor can also perform this GC-O techniques comfortably, and they can each have their own personalized nose cone for hygiene purposes. So like I mentioned, with this recorder function, this is how you will look like. First, when the human assessor, after inputting their information with the recorder, you will obtain an olfactogram, which you see at the bottom here. Then, whatever they describe for each of the aroma compounds will be added onto the olfactogram as well as the chromatogram. So that it's good for you to cross-reference and compare the results you obtain from the detector and from the human assessor, which makes this technique very widely used in the off-flavor, flavor, and fragrance analysis. In fact, in a recent development, right now there are interest of collecting fractions from the GC for further analysis. So for example, by inserting a sorbent tube instead of the nose to collect certain fraction of the GC chromatogram, I can collect this fraction and then use for a later sensory evaluation, or we can re-inject it into another GC column of a different polarity to perform like offline GC hard cutting for better separation. Or we can collect after multiple runs to increase my detection or decrease the detection limit for better sensitivity and better identification of the aroma compounds. So GC-O itself is a technique, and there's quite a few information obtained after GC-O. So for every compound coming out, like I mentioned, you get to know whether there's odor from the compound. If there's an odor, you can also state be recorded to describe what the odor is. So as described earlier, you have plenty of different descriptions like sweet, fragrant, floral, smelly, etc. After the description, you can also tell you how long you smell it based on our recorder. And you can, because with the intensity device, you can also quantitate how strong this odor it is to the human assessor. So with all this information, there's actually a few techniques developed to perform a GC-O project. So the most direct method is known as the direct intensity method, where you just do a GC-O run of a sample, and you perform and indicate what is the strength, what is the detection. But to do a further analysis, which was actually covered nicely by Associate Professor Dr. Yawapa earlier on, we have another technique called the dilution to threshold, which is also known as aroma extract dilution analysis. So if you need to know even more information of how to compare across different odor compounds in a sample, this is a good technique where you keep diluting the same sample and get the same 1 to 2 human assessor to do this project to understand which compound still remains its odor strength even after high dilution. And that will give you the information that that compound is of a stronger odor strength. Or if you like to know how this samples is reflected in a population, you can do detection frequency, or also known as nasal impact frequency technique, where you have a single sample but have 6 to 12 or even more human assessor doing the GC-O, and by combining all their feedbacks, you will know which of the compound is most highly detected by the most people in the group. So from there, you would then know which compound is the most sensitive to a general human population, and hence its importance, and then you can use it for your subsequent project. So all this information can be actually compiled and studied with the olfactory data integrator software, where it helps you visualize the various MS results from the different instruments, your different detectors that you have, if you have mass spectrometry or if you have FID, and it has a built-in AEDA aroma extract dilution analysis or panel analysis processing, where it combines all the GC-O data you get across multiple runs to help you improve your GC-O project's data analysis. After all this, if you still have difficulty in pinpointing what that compound could be, which is a huge struggle in most samples aroma analysis, we have a novel linear retention index database, also known as Aroma Office 2D, which has more than 100,000 entries of flavor compounds from various different journals. So they are all information actually from published peer-reviewed journals. So with this, you can do improved identification by cross-referencing the information from your mass spectrum and from the retention index you obtain from the system with all this other researcher that has published their work. And you can also cross-reference with the odor character which a human assessor or the other papers has reported. You can also compare 2 different columns information. So all in all this helps you in your aroma analysis. But in order to have the perfect best aroma analysis, you have to improve your olfactory GC-O sensitivity. So if you did not inject enough into your sample, you may not be able to smell what you need to smell. So how do we further improve this sensitivity of our GC-O? So we have to look back into the aroma analysis workflow. So in the aroma analysis workflow, in the first step after you got your sample, you have to first do sampling and proper sample preparation. So nowadays for food preparation, we will tend to go towards solventless, because when you use solvent to extract, it may not be the correct proportion or correct composition of what was being perceived from a human nose when you smell it from the food. So to do a solventless would be a better technique. And nowadays with limited samples or to run more runs from a sample, we tend to go towards miniaturization. So with the same amount of food sample, you can do more runs and get more data out of it. Or if you have lesser sample, you don't have to worry about it. Together with miniaturization, we can also do automation, which then can decrease the number of manual work and really can focus more on doing proper aroma data analysis. Of course, after doing all this sample preparation, we will go into separation where I did mention using gas chromatography. Or if you have complex samples, you can actually look into using multi-dimensional gas chromatography. After separation, you will have to do detection, and the more common detection techniques such as mass spectrometry, which is commonly used for identification and quantification, or FID, which is very good for quantification, and of course, the olfactory detection port, ODP, to attain aroma feedback from the various human assessor. And then, of course, last but not least, you have to do your data analysis such as ADA or panel analysis, or using our aroma office for unknown compounds. And subsequently, for example, as covered, you can even do like PCA analysis to differentiate the different ethnic samples. So back to the question, in order to improve our detection, we have to go back to the very first step. To increase our sensitivity, we have to increase the mass on column. In other words, the amount I inject into the GC, maximum, but not overloading the system. So how do I increase the mass? A simplest way, of course, the first part would be increase of sample. But like I mentioned earlier, the reason why we move toward miniaturization is because when your sample gets larger, it's getting harder to sample a correct representation. And also you have to worry about getting enough sample for repeatability and reproducibility. So the best way to do it, the next way, is to improve your sample preparation technique. There are actually various sample preparation techniques that are now available. So some of the techniques that are commonly used are such as headspace extraction and solid phase microextraction, whereas recent trend move towards the more advanced techniques such as durable soft leaf extraction, thin film solid phase microextraction, and dynamic headspace. So for the second part of my talk, I'll be focusing on all these various different sample preparation techniques, on how to work with them and what is their advantage and disadvantages. So in basic techniques such as headspace extraction, it's very easy to conduct them. All you have to do is to prepare your sample in a sample vial, heat it, and then just collect the headspace into a large volume syringe and inject into the GC. It's very simple, quick, and easy to teach another user on this technique. Similarly, we have solid phase microextraction. You also have to first heat the sample to get out your aroma compound from the sample. Then instead of getting just the headspace, we will insert a needle that has a sorbent in it, sorbent fiber, where the sorbent will then extract all these aroma compounds in the headspace, and then subsequently insert this sorbent fiber into the inlet of the GC for desorption. So these two basic techniques are very commonly used nowadays by plenty of customers in the food flavor fragrance industry. But the problem with them is that even though they are easy to conduct, you also usually face with low sensitivity, where if you need to identify certain small, low concentration aroma compound, you have difficulty trying to study them using GC-MS. So moving on, the next best technique would then be twister. It's a solvent-coated magnetic stir bar where it has a layer of PDMS phase wrapped around this magnetic core that's inside an inert glass casing. So this stir bar, also known as twister, can be used for extraction. Because of its higher phase volume, we would expect better results than headspace extraction or solid phase microextraction. So to perform extractions with this stir bar, you can either put it into your sample if there's a liquid phase to perform stir bar sortive extraction, or you can put it above similarly as described earlier for headspace and for SPME to perform headspace sortive extraction by placing the twister above. After the extraction, you can then send them to a thermal desorption platform to be analyzed with a GC-MS system. Or if you are going to study maybe some compounds that are not compatible with GC, you can even do twister back extraction by extracting back into a solvent and inject it into an ELSIS system for analysis. There are two main types of twister. We have the standard PDMS twister, which are the more commonly used for flavor and off-flavor analysis in food and beverages. But if you are interested in phenolic compounds, e.g. silicone twister will have better sensitivity for these compounds. So a simple comparison to the basic technique, such as solid phase microextraction, we can see here in direct immersion, meaning you put your solvent phase directly into the sample, we get much higher recovery with our stir bar sortive extraction compared to SPME, and also in headspace mode, where we in headspace sortive extraction also achieve higher recovery across compounds of different polarity compared to headspace solid phase microextraction. And this is because, as I mentioned, with higher phase volume of the solvent on the stir bar, it gives you much capability to do better extraction efficiency and higher recovery. So here I have an example to also show that twister bar can also use in extracting, for example, in this case, herbal tea extract. So by putting in the stir bar and extracting it for 1.5 hours, you can see that we can achieve all the aroma compounds from the various herbal tea extract nicely. And I get very nice repeatability and reproducibility across all the compounds with an average of 3.16%. Or in this application, we did the same twister experiments with 3 different brands of natural coconut water. At first glance of the chromatogram, you can see that they look similar and yet not. We can see from retention time-wise, the compounds are all quite similar, but the ratio of them is actually differing from one another. So taking into closer look, for example, the levels of the different octanoic, decanoic, and doctanoic acid, all the different acids, they actually vary significantly different across the brands. Similarly, for the different key flavor compounds or aroma compounds, such as this isoamyl acetate and gamma decaplactone. So these differences, right, is key. You need to be able to see these differences, which depends on the technique, sensitivity. And by seeing these differences, you can then study what is the reason that causes these differences in these compounds or aroma compounds. And it could be due to like processing or storage, or even be due to where this coconut comes from. The different origin of coconut could affect what its aroma profile as well. So this shows that this twister is really a very fast and easy, powerful technique to perform flavor analysis in the various food. So if this technique is still not sensitive enough for you, we can, because of its design, we can actually position more than one twister in a single sample. So this technique is actually known as multi-stir bar sortive extraction. So by placing more than one twister, you get higher solvent, which gives it a higher extraction efficiency. In fact, we can even dissolve more than one of them together at the same time so that you still get one chromatogram and one data analysis to work with. So with higher sensitivity and yet not necessarily more data analysis work. So taking a look at these results here, you can see that with more twister added, I get much better recovery, especially for the more polar compounds, due to, as I explained, with the higher sorbent phase, you get the higher recovery. Another technique that we have here is the thin film solid phase microextraction, which was recently developed just a few years back. It is an extension of the regular solid phase microextraction, where it is much more sensitive due to its increased surface area and phase volume. It is designed to have, is actually just a carbon mesh sheet implemented with the sorbent phase such as PDMS DVB or PDMS carboxene, which are commonly found in solid phase microextraction fiber. So to perform extraction with this device, you have to do is to slot it into a metal holder, put it into the sample vial either as a headspace or immersion mode, or you can heat the sample to enhance the extraction efficiency. After that, you then take it, remove it, dry it, and place it into a thermal desorption tube and load it onto the tray onto the autosampler. Then, to thermally dissolve it, we bring it over to the thermal dissolver, where it will heat up so as to extract out all the aroma compounds that it previously extracted. We will cryofocus in the inlet before it mimics an injection by quickly heating up and sending all the compounds into the GC for separation and MS or FID or ODP for detection. So a simple comparison with solid phase microextraction in this study of a wine, you can see that the amount, the number of compounds you can extract is much more, and each of the compounds intensity is much higher. So with this, you can actually compare the different compounds, the intensity differences are much better thanks to this higher sensitivity of this technique. Or in this example we have here where we does a Headspace thin film extraction from a cocoa flavored coffee. So you can see that from this aroma compounds, we can capture both the aroma from the cocoa flavor where you see chocolate nutty, and we can also get the flavor from the coffee itself, which is the nutty roasted flavor, for example. Or in this example, in the dark chocolate, you can see both the key aroma compounds and the pyrazine compounds can both be actually viewed, identified easily in the chromatogram obtained. In fact, as I have covered, twister and thin film SPME are actually of very different phase, if you have noticed, because they are designed to work independently or to complement each other. So if we can combine them together, we can get greater softness phase for even higher extraction efficiency. Both can then be dissolved simultaneously into one tube so that you only get one GC run and one chromatogram for analysis. So of course, again, you can either perform them in the immersion mode or in the Headspace mode. So this work has actually been published very recently. We collaborated with one of our customers, Mainsea Private Limited, where we incorporate these two techniques into a single extraction workflow, and we optimize them individually. And we found that by combining, we actually get improved linearity range, sensitivity, and recovery. And this was actually applied and successfully applied onto 40 common aroma compounds that has very various chemicals and physical properties. And interestingly, the optimized settings, right, are actually similar, indicating that when we convert from the twister only, thin film only, or combining them, the techniques, the method, optimization or extraction settings can actually be easily translated across these different techniques. So if you're interested, we have a link here for you to download and view the work. And of course, last but not least, that we have another technique called the dynamic headspace. Dynamic headspace is a bit different from the other techniques because it is no longer equilibrium based. it actually uses a flow of carrier gas so that your sample can be constantly purged. And by constantly purging your sample, this actually allows dynamic headspace to achieve higher sensitivity than the static headspace technique. So you can see here with the automated dynamic headspace module, all you have to do is just to load your sample onto the automation tray. And then you can see that it will automatically bring the sorbent tube over, turn on the gas flow to constantly purge your sample, bring up all the aroma compounds up to be trapped on the sorbent tube. You can have a selectable dry to prevent water condensation on your sorbent tube, and then subsequently automatically bring the sorbent tube to the thermal dissolver for thermal desorption, so that you can then send it into the inlet and GC-MS for separation and detection. So a comparison with the basic technique, you can see here that dynamic headspace gives much nicer chromatogram with more compounds of higher intensity, because it's a more universe and less sensitive selective technique, which makes it much more suitable for flavor profiling of your sample. An example here, you can see that in these extractions of 2 grams of fresh strawberry, all the key strawberry notes you can see here are nicely extracted in clear distinction. In fact, dynamic headspace module can also be upgraded to having this multi-volatile method options, where in a single sample, you can actually use more than one sorbent tube to perform extraction. So you can see here in the application to brewed coffee, we use 3 different traps of different properties so as to trap different compounds of various properties and achieve near 100% recovery for all of them. If until here, you don't have a technique that is more suitable or is still not sensitive enough, or you would like to use much bigger sample, you can upgrade the dynamic headspace to dynamic headspace large. Here, where you can put sample size of invert out to a liter. So for example, here, instead of cutting the poor flower up, because in a flower aroma analysis, it may be difficult for you to do sampling or to cut it down. To do the aroma out of a flower, it's good to just put the whole thing in and study the aroma profile. So in this case, with the use of dynamic headspace large, we can then study a whole carnation and its aroma profile coming out of it. So with this, I'd like to go back to this aroma analysis workflow. So this whole workflow, every single steps are important. You can see that we covered the first step where we cover solventless techniques and how we miniaturize and automate with various sample preparation techniques that you can find that may be suitable for your various different sample. And of course, good separation of technique in different GC, where you have to use the correct column or even multi-dimensional GC for more complex samples, and good detection, especially the need for an olfactory detection pod, so that you can get aroma feedback, because aroma and the mass concentration are not related at all. So with this, I would also like you to bring, due to time constraint, we actually have a lot more application in the field of food and beverages or even flavors and fragrances. We have plenty of application in the link here. So if you are interested, feel free to go and browse. They are free to download for all of them. So with this, I'd like to thank my colleagues for the presentation information today. And of course, I would like to thank you for your attention for this past 30 minutes of my presentation. And let me know if you have any question that you can discuss on. Thank you.
Thank you very much, Dr. Liew. Well, we have some questions. The first question is, which technique you have introduced is the best?
Oh, that's quite a good question. So actually, it depends on your sample. So we have to first know what is your sample you want to look at. What is the aroma profile that you want to look at in the sample? and what concentration they are at. I'm not saying that the basic technique is not good or the advanced technique is always the best, but if your sample is of strong concentration, you should stay with the less sensitive technique. Or with a stronger technique, you will have to do like split ratio. So for me, my personal favorite after testing all the different techniques, I actually prefer the dynamic headspace because of its ability to be automated, and it's much more universal and non-equilibrium based, which I like, so that it can always get more than equilibrium based concentration. Yeah.
All right, thank you.
And the second question, I'm using SPME now, and sometimes it's difficult to see result. What would you recommend?
Okay, so if you have difficulty with SPME, then you can follow the flow of my presentation today, where you can then try the next technique such as the twister for stirred absorptive extraction or thin Film-SPME because of their higher sorbent phase to get better recovery and then allow you to pinpoint and extract out that unknown compounds that you have difficulty with the solid phase microextractions. Or in fact, you can also go to dynamic headspace technique depending on your type of samples. So if you have more information, we can discuss this further as well.
Well, we have more questions. What technique would you recommend for analyzing of odor from coffee? Wow.
Oh, so if you would like to understand off odor of coffee, actually we have quite a few works that use dynamic headspace for off odor coffee. It's because off odor itself is very hard to pinpoint. They are usually not very well detected by mass spectrometry or FID. You usually need a separate, like a sulfur detector to study especially the sulfur notes in your coffee off odor. So usually to study off odor, they use a combination of different techniques. That means you cross-ref. So like I described earlier, there's no one best technique. In fact, different techniques can complement each other. So we have a few work that also use like twister and also dynamic headspace. And together, like I showed earlier, we have even the multi-volatile methods to improve the sensitivity so that you can then do a better analysis of the off odor from coffee.
And the last question, I'm using GC-FID. Can ODP be installed on the system?
Yes, so it's not necessarily just mass spectrometry. So you can easily install a splitter to split between any GC detector that you have and install it with an olfactory detection port so that you get both the results from the FID in this case and the results from your human assessor when they smell the compounds coming off the GC column.
All right. Well, once again, thank you very much, Dr. Liew, for sharing with us an interesting story.
And before we move to the next section, let's have a short break before we move to the topic, pandemic implication, health trends, and consumer behavior amplify. See you again in a while.